of the real number system. So I started you off like the natural numbers, what comes after that, and then so on and so forth. And then add those two things, and then multiply those two. So try it on your own for a minute or two. Yeah, try and put some kind of logic and order into it. And then test your sheets. So, there we go. Number one, writing down all the subsets of the real number system. Who can do it really quickly? Daniel, what do you got, buddy?
Whole numbers, integers, rational, and irrational.
Yeah, the whole numbers, the integers, the rationals, and the irrational. Nice job. Now, all of these make up the real number system, right? Yeah, you got the natural numbers, the whole numbers, the integers, the rationals, and the irrational. That's quite a lot of numbers in there, right? Now, there's this whole other number system called the imaginary number system. Imaginary number system, which we're going to get to today. So it's like this whole other playing field separated from the real number systems. Okay, when you added 2x plus 3 and 6x plus 4, Olivia, what'd you get?
I got 8x plus 7.
8x plus 7. Is that the right answer? Can we confirm that? Good. Okay, and then on the third one, if we multiply 3 minus 4x and 7 plus 3x, Alejandro, can you confirm what we got there, buddy? Negative 12x squared minus 19x plus 21. Do we agree?
Yeah.
All right, great. Let's go on to this first one here. First box. This whole thing is called complex numbers, 5.6. Should have written that down for you. All right, when you start to talk about complex numbers, you have to sort of back up and talk about the imaginary unit. That's where the whole thing begins, all right? And you may recall that we could never take the square root of a negative number. So I put the first negative whole number that we take the square root of, -1. And everything about imaginary numbers is based off of the idea that the square root of -1 is the number, what does that say? I. The square root of -1 is the number I. Very, very strange, right? It stands for imaginary unit, okay? So the square root of -1 is the number I. That's the definition of imaginary numbers. Now, once you got that part down, then we start to talk about the pattern, okay? So I want you to see if you can discover the pattern, okay? Now, my computer program recognizes I as a capital letter, but usually it's written like it is right here in math books as like this funny little I thing, okay? So, if I is the square root of -1, then, well, what would I to the first be? That would just be I, right? So if I ask the calculator, I just get I. Okay, now, what would I squared be? So if I put a parenthesis around this, and squared it, what would I get? -1. So I squared must be -1. Okay, I squared is -1. Now there's a pattern here. What would I to the third be? Yeah, Mr. Brim. +1? You're close. Let's see here. Let me break this up for you. And what's the root of -1 defined to be? So this is -I. Very good. -I. And then, now, check it out. If I were to take I to the 4th, well, since I squared is -1, couldn't I just square that thing? What would I get? There you go. So I to the 4th is equal to 1. So let's review. I to the first is just I. I squared is -1. I to the third is -I, or the negative square root of -1. And then I to the 4th is +1.
Why is these? How do you get I3?
You got it. Exactly right. Okay, now, here, check it out. What is I to the 5th? Olivia, you're correct. What's I to the 6th? -1, correct. What's I to the 7th? -I, correct. And what's I to the 8th? Okay, so what have we learned here?
Oh, it's a pattern.
There's a pattern, and there's only 4 possible answers when you take the imaginary unit and raise it to a power. Any power. There's only 4 things it could be. Isn't that weird? So my question then is, what is the pattern? How do you figure out what the pattern is? And how do you use that pattern to figure out what out of the 23rd, out of the 56th, and out of the 702nd is going to be?
Arithmetic.
Yes, arithmetic is good. Well, okay. How many possible things can it be?
4.
Yes, Olivia.
Just so you divide that number by 4, and if it comes out an even thing, it's going to be the first one. And then if there's, I don't know how to explain that.
You're totally on the right track.
Divide 56 by 4. No, how many times does 4 go into 56? And if it goes an even number of times, then it's going to be the same as I the first. And if it goes with a remainder of like 2 things, it's I squared, and 3 is I the third, and 4 is I the
You are 100% correct. So check this out. This is how it works. Can I show you guys? She picked up on something very, very cool. I the 23rd. Let's see here. If I take 23 and I divide it by the 4 possible things that it could be, right? How many times does 4 go into 23? Well, let's see here. 4 goes into 5 times, which is 20, right? And then I have a remainder of 3. So could it be that I to the 23rd is the same thing as the I to the 3rd? Because it goes through 4 full times and then another 3 times. So my answer... 5 full times. Thank you. So my answer should be what? Negative I. Is it, ladies and gentlemen? Woohoo! We did it right.
So it's the remainder.
So you're looking for a remainder. Correct. Now, hold on a second, because when I say remainder, people get a little bit upset. What about I to the 8th? Because 4 goes into 8 exactly 2 times. So what's the remainder? 0. And what's anything to the 0 power? 1, which is why that's 1. Okay, so now, can you guys figure out I to the 56 for me, please? What's it going to be? Yes, Mr. Brand, what'd you get? You think it's 1? And you would be correct. Nice job. Yeah.
Well, is it always going to be the same as like 1 and stuff? Is it going to change based on if there's any root negative 1? Is it always root negative 1, or might it sometimes?
Yeah, root negative 1 is the basic definition of an imaginary unit. That's the one that we start with. Yeah. Yes. What's this I of the 702?
Oh. I didn't do that.
Oh. Yeah, what'd you get, Bram? Negative I. You are no. Negative 1. I got negative 1. Huh? You divide by 4. Yeah, because there's 4 things it could be. Yeah. That's all there is to it. Okay, a complex number, right? This is box number 2. A complex number is a number in the following form. It looks like this. It looks like A plus or minus BI. Okay, now there's 2 parts to a complex number. There's the first part, and that is the real number part. That's a terrible arrow. That's the real number part. And then the BI in the back, that's the imaginary part. The imaginary number. So when you put all of these things together, when you put a real number paired with an imaginary number, it creates a complex number. Okay? So a complex number is made up of 2 parts. A real part, which comes first, and an imaginary part, which comes second. Make sense? All right, sweet. So you might be asking yourself, what do we do with complex numbers? Well, we add them, subtract them, multiply, and divide them, just like we do with real numbers. So, third box. Let's add 2 complex numbers, right? So, this is a complex number, and this is a complex number, and we want to add them together. So check it out. We're going to add the real parts together, 2 and 5. How much is 2 and 5?
7.
Yeah, so that's going to give us 7. And then we're going to add the imaginary parts together.
3i.
Yeah, 3i minus 6i is how much? negative 3i. There you go. And notice we get a real part, which is the front part, and an imaginary part in the back. Together they make a complex number. Pretty straightforward, right? Just like we did in the warm-up, when you added those together, you add like terms, so you can kind of think of it as a variable, right? All right, let's try this one. Do you remember the warning first week of school? That's right, the negative sign, yeah. So let's rewrite this as... What if I rewrite this as 3 minus 4i minus 5 plus 6i? Do you guys see the warning there? Yeah, remember to distribute your minus sign into both terms of your complex number there. So, let's see here. Let's add the real parts together. How much is 3 minus 5? Negative 2. How much is negative 4 plus 6i? Positive 2i. Now, you can leave it like that, or you can leave it as negative 2. You can factor out a negative 2, which gives you 1 minus I. Either one of those is okay. That one or that one, my squiggly. That looks terrible. Let's go, Dioria. Get it together, buddy. There you go. All right. So either one of those will work out just fine.
You guys recognize that you wanted to highlight that?
Yeah. Using a highlighter thing.
Oh.
Okay. So adding and subtracting complex numbers, really easy. Nothing too exciting there. The actual fun and cool thing happens when you multiply and divide them.
Can you get an imaginary number squared?
Oh, we're going to do that right now. I'm so excited. 2 examples for you, then we're done. So, I got 3 plus 2i, a complex number. 5 minus 3i, another complex number. I want to multiply the complex numbers together. So let me refer you back to the warm-up. What did you do for number 3? Foil, and use distribute. So let's do the same thing here. So how much is 3 times 5? So I'll use the first. I want this one. So it's going to give me 15. Outer, which is a minus 9i. Inner, which is plus 10i. Is that right?
Yeah.
And then finally, last,
Minus 6i squared.
negative 6i squared. Now the warning is right here. I'm sure some of you already see it. Do you see it? Okay, cool. I'm going to highlight that because that's the warning.
I squared.
Yeah, very, very good. So here we go. Check this out. In the middle, of course, we can combine those two things, right? So this gives me 15 plus I minus 6i squared. Now, I squared has a certain specific value, and we learned that back in the imaginary unit. I squared is how much? Negative 1. So we're going to apply that over here. So bringing this over, I get this. I get 15 plus I minus 6 times negative 1, because I squared is negative 1, right? So that means I really have 15 plus I plus 6, which is 21 plus I. And that, my friends, is the answer. Now, here is something that's really, really, really strange. Okay, I want to explain this to you. We had, to start with, we had 2i and 3i. What types of numbers are those? Those are imaginary numbers, right? There are two imaginary numbers hanging out over an imaginary number land, right? As soon as you multiply them together, they get bumped into the real number system and become 6. Isn't that strange? Two numbers over here that are not real numbers become real numbers when they get multiplied together, and they can get bumped back over to the real number system. That's weird, isn't it?
Yeah.
It's super trippy, right? Okay, last example, then we're done for the day. 10 over 3 minus 2i. Whoa. Whoa is correct. Okay, so this is the final example. We're dividing a complex number, right? Okay, there's a trick to get yourself out of this crazy situation. And the trick is multiplying by something that looks like this. 3 plus 2i, 3 plus 2i. Somebody tell me, what is that thing called? It starts with a, yeah, you guys got the conjugate. This is the... So we're going to multiply by the conjugate. But don't worry, the conjugate is still just a fancy 1. So we're okay, right? Now here's what you get when that happens. here's what you do for yourself. So the top's going to be 10 times 3 plus 2i. No problems there. The bottom, 3 times 3, 9. 3 times a positive 2i is 6i. Negative 2i times 3 is a negative 6i, so something really nice happens right here. They cancel out, right? And then I get negative 2i times a positive 2i is a negative 4i squared. And again, we're not going to forget the trick with the I squared. You guys with me? Okay. So, here's what I get for the top. I get 30 plus 20i. In the denominator, all I have is 9 plus 4. Do you guys see it? Yeah, this is going to be 9 minus 4 times negative 1. Because the two things highlighted get canceled out. So that gives me 30 plus 20i, all divided by how much? 13. Now, in order to write this in standard form, which is this form, a plus or minus bi, we need to separate our fraction to get a final answer of 30 over 13 plus 20 over 13i. Now, what does that do for me? What does that clearly identify? Yeah, that tells me that this part is the real part, and this part is the imaginary part. And you put them all together and you get a complex number. Alright? What do you guys think? Easy, medium, or hard? Easy to medium. Cool.